Episode 1, Upstream Petrochemical. Some examples of companies in this industry include ExxonMobil, Shell, BP, and Chevron. These names may be familiar to you from visiting the gas station, but these companies are so much more. Because there's so much diversity in the roles of chemical engineering in this industry, I've split this episode into two parts. The upstream petrochemical industry is for those who want to get their hands dirty, both figuratively and literally, with chemical engineering. This industry is all about finding and extracting crude oil from reservoirs in the earth. Interestingly, but perhaps not surprisingly, crude oil can look and behave differently depending on where it comes from. Therefore, chemical engineers have the challenge of producing a consistent product from an inconsistent raw material. The downstream petrochemical industry will be the subject of a future episode, and the focus here is refining that crude oil into gasoline and other chemical products. The first question of the petrochemical industry is where. It's bad practice to indiscriminately drill holes in the Earth's surface without prior knowledge of how much oil exists in the reservoir, if any at all. To answer this question, petrochemical companies have entire teams dedicated to exploration, which consists of engineers, geologists, and others. A popular method is using a computer model to predict the location and composition of the oil ahead of time, such that the company can project the expected profit of drilling in a particular location. The map on this slide shows the amount of oil drilled in the countries of the world. Hotspot locations include the Middle East, Russia, and Canada. Therefore, this is a job that can take you all over the world. One of my good friends from college was stationed on the North Slope in Alaska when he worked for ExxonMobil, and he would tell me that he'd frequently see polar bears while performing his job. Although I have to be honest and say that I'm not sure if this is true or not. Regardless, he really enjoyed the opportunity to travel and see such a remote location that few others have the opportunity to see. I'm going to focus on the location closest to our home state of Florida, which is in the Gulf of Mexico. This map is a little outdated, but it shows the locations and sizes of offshore drilling rigs. Notice that they're mostly off the shore of Texas, Louisiana, Mississippi, and Alabama. I'm not aware of many oil rigs near Florida, and I'm not sure why, but my speculation is that there's concern for our beaches and tourism. Another observation to make here is that larger rigs tend to be further offshore, possibly because it's harder to drill in deeper water. So rigs out this far have to produce more oil in order to be worth it economically. This brings me to the second question that chemical engineers must ask. The oil is located in Earth's surface, which can be approximately 1 mile below the water surface. How can we get down there? These are cartoon images showing some different types of drilling platforms. For shallow water, the platform can be fixed right to the surface, but for deeper water, they are usually floating. Most of the famous or coolest named rigs are spars. For example, these are images of the Mad Dog spar, operated by BP, and the Perdido spar, operated by Shell. At one point, Perdido was the world's deepest spar at 8,000 feet, but I'm not sure if something else has taken its place. I've always been intrigued by the names of these platforms. Perdido is Spanish for lost, possibly owing to how remote it is. I'm not sure if I'd want to work on something named Lost. From the oil rig on the water surface, we next need a way to transport oil from the hole to the surface. This can be done by assembling a drill string. In 30-foot sections, pipe is assembled and lowered to the surface in stages. A third question, and without a doubt the most important question in all of chemical engineering, is how can we operate safely? One of the specific hazards of this industry is the tremendous pressure inside the oil reservoir. To counter this pressure, the pipe is filled with a dense substance called drilling mud. The height of the column of drilling mud in the pipe is enough to resist the pressure inside the reservoir. The term for an uncontrolled release of crude is a blowout, which can occur if the pressure isn't accounted for properly. An aptly named piece of safety equipment that prevents blowouts is called the blowout preventer, or BOP for short. By the way, if you talk to an engineer or anybody who works in the petrochemical industry, expect them to use plenty of acronyms and jargon. It can sometimes feel like they speak a completely different language. Just expect this, don't feel inadequate, and don't be afraid to ask them to explain their terms. The consequences of a blowout can be devastating. On April 20th, 2010, the most infamous blowout in American history occurred on the Deepwater Horizon drilling platform, leaving 11 people dead, 4.9 million barrels of oil spilled, and unfathomable and unquantifiable damage to wildlife that still persists today. The left image is Deepwater Horizon in its normal state of operation, and the right image is the fire that burned for multiple days on board. The Deepwater Horizon incident was adapted into a 2016 movie starring Mark Wahlberg. While it is only a dramatization, I personally think it should be required viewing for all chemical engineers. This incident is a solemn reminder of the pledge that we must take as engineers to resist the temptation to ignore warning signs and cut corners, and instead choose to hold paramount the protection of health and safety of society above all else. The lifestyle of working on an offshore drilling rig is certainly unique. You may have been wondering how you even get there, and the answer to that is, of course, by helicopter. Here again, safety is of the utmost importance. In the event of a water landing, helicopters are prone to flipping upside down because of the weight of the rotors. Petrochemical companies have helicopter safety training courses that involve an actual helicopter and a huge swimming pool. When I was in college, I had the opportunity to complete this training. Even though it was only a simulation, the adrenaline rush of being flipped upside down was unforgettable. Something else that stuck to me was the attention and reverence that companies like ExxonMobil and Shell have for safety. Even though flying in a helicopter might be terrifying for some, the safety protocols and planning that are in place are very reassuring, and you should feel safe working for these companies. A common scheduling arrangement is to live and work continuously on the rig for 2 weeks at a time. This may sound grueling, but this schedule is coupled with 2 weeks off after that. Another benefit is the high salary of these types of jobs. This is a very popular arrangement for young chemical engineers who may not have family obligations just yet and wish to travel the world, both as part of their job and as part of their extended free time. In case this lifestyle doesn't appeal to you, you can still work a normal schedule in the upstream petrochemical industry too. These are images of the newly constructed ExxonMobil campus in Spring, Texas. I visited this campus and can attest to its beauty and general awesomeness factor. I call this campus the Google of chemical engineering because of all the amenities that make it a fun and comfortable place to work. That will wrap up this episode of Industries in Chemical Engineering. See you in the next episode.